All right, thanks for joining our June user group. And as you just heard there, we are recording this session. We do make them available on our YouTube channel afterwards. We thank everyone for joining as always. Everyone's lines are muted since we're using the webinar function, but feel free to type in the chat or the Q&A. And if you really want to ask a question live, you can raise your hand and we can unmute you if we choose to. Joining me today, well, first, my name is Wayne Welk, automation specialist out of New Orleans, and joining me today is Mike Masterson to help with the presentation, automation specialist out of Houston. And we also have Luis Ramos on the line too, who might chime in there occasionally. So we've kind of titled this one today, Logix Network Architectures. We also kind of called it Redundancy Architectures, mainly for the network. Kind of our original intentions were, if we had a redundant ControlLogix pair, what are some of the approved redundant architectures for networking? And that's kind of what kind of led us. But we're going to talk about a few other things in here too, just to kind of get a little general overview on some networking stuff. So first off, as we traditionally do, kind of what's coming up from our seminars in July, we will do a tech talk. And the date is kind of set, I believe, so it'll be kind of late July 27th. And again, our tech talks are usually our shorter form sessions, and we'll do one on remote access solutions. The details on that haven't been published yet, but there will be soon. And this will be a good overview on various remote access solutions from Rockwell, E1, ProSoft, and our other technology partners as well. And then the user group for July will be a modernization topic. That date has not been set yet, but we'll get that defined here very soon, probably the week before the tech talk.
Yeah, Wayne, we do have that set, at least for Houston. We just haven't published it yet.
Excellent. Yep. And this month, we're doing something a little different with the user group. We had been going the in-person route. We decided to do this one as an online only and invite everyone. And then Houston is actually doing this exact same seminar tomorrow in person. So if you like what you hear today and want to hear it again tomorrow, you can catch it in Houston, which I think will be live streamed as well. And last thing here on our events is our updated website. We show this slide every time as well, but reynoldsonline.com is the place to go. That's where we have our training and events calendar and schedule for future user group and tech talks, as well as our archive of previous events and any blog articles, podcasts, videos, and other news. So please keep this bookmarked and check it out. All right, and with that, like we said, I introduced ourselves. My name is Wayne Welk, and Mike Masterson will help with today's presentation. So quick agenda, we're going to talk about just various network topologies, a quick kind of refresher on the CPWE, and then Mike will pick up on segmentation and DLR, device level ring, and then I'll finish it out with a show and tell on PRP, or parallel redundancy protocol. So network topologies. So first here is just kind of showing the convergence over time and going from legacy, very flat type or open non-resilient networks, and that's kind of where we started, right? And that's as we kind of progressed in our move from the from the legacy network days of twisted shielded pair type networks, and we first moved into Ethernet. We kind of mimicked those same kind of legacy networks that we were used to, and our kind of our beginning days of Ethernet were things that we probably would never even want to consider doing today, but they were simple and easy, and we kind of went that route. And then over time, as we learned and got better, we got into a more structured approach, and then even to the converged plant-wide Ethernet approach that we'll show here in a few. So this was really just to kind of show the evolution, kind of how we have moved, and progressed over the years with Ethernet networking. And we'll definitely elaborate in the VLANs and segmentation here in a few moments. So another kind of refresher is just the types of switches is kind of important to understand, these devices on the plant floor, part of the networking. And we kind of, have them organized here in three ways: managed switches, unmanaged, and embedded switches. And of course, we would strongly recommend and encourage managed switches in your applications. They will give you the best performance, the best amount of segmentation with VLAN capability, diagnostics, security services, network resiliency capabilities are in the managed switches, and loop preventions as well, which is very important. Advantages, disadvantages. There's always trade-offs, everything. So, having a disadvantage column there. But typically a managed switch is definitely more expensive and will require some level of configuration to get going with it. Not that it's difficult, but it does take a little extra set of skills perhaps to configure the managed switch. An unmanaged switch, of course, is, its name implies, is unmanaged. It's going to be really, simple, not a whole lot of configuration whatsoever. But you kind of lose all those capabilities of the managed switch. You don't have the security, you don't have the loop prevention, you typically don't have the resiliency support in there as well. And then for us, an embedded switch, that's kind of where typically we're looking at things like an ETAP, and even our 2-port Ethernet modules for the ControlLogix. That would be an embedded switch. Those basically, we got 2 Ethernet ports but 1 IP address. So again, very limited somewhat there as well. But they do offer some level of network resiliency and loop preventions. So there are some good capabilities in the embedded switch. Just monitor our chat here too. Yep. Okay. So just again, real high level on our different topologies. So first, looking at a linear topology. Again, as we looked at the transition from our older legacy networks into our Ethernet networks, we kind of mimicked that here, and that's what the linear network topology is. Really flat, almost like a daisy chain approach. Here in this diagram, we have switches, and we just kind of daisy chain from switch to switch per se, and then tag on devices. The advantage of this is, hey, it is pretty easy, right? Probably a limited amount of cabling. But the biggest disadvantage of this is that if there was any kind of break in the network along the way, like if we had a break in the network here, or if this switch here died, well, everything downstream is obviously gone and no longer visible to the controller. So, it does work. We do see this network, but there are some inherent risks and disadvantages of that linear topology.
Yeah, provided it's on a closed network, this will fine as long as it's not connecting to the plant-wide network. If it's a small network, this will work. And in fact, you could probably use an unmanaged switch in there. The problem is none of our networks actually reflect this very often these days.
Yeah. So moving up would be the star topology, and right, this was just basically taking kind of the same amount of switches and cabling there, but now instead just distributing from one central switch in that star type topology. So again, easy to configure and implement. And in this case, if we lost one of these links or one of these switches, well, we only impact this particular area or zone of the plant floor, and the rest of the system can continue to communicate and potentially continue to operate uninterrupted. But taking that one step further, the redundant star approach, right? So sometimes we see specifications or requirements for preventing, just a single connection from that top switch down to the work area, and have a redundant star topology. So with some of our resiliency protocols that are built into these switches, we can do that, such as Ether channel or flex links. We can have dual feeds down to a switch and a star topology. And if we lost one port or one cable, then we can continue to operate in those areas. course, every time, this life's full of trade-offs. So, going this route just, just increases the complexity. Of course, it increases the cost for additional wiring, but it does start to increase the complexity of your switch configurations. So, so it gives you more potential for more uptime. And last topology, of course, is the ring. And this is probably one of our most common, architectures we'll see on the plant floor because it's very simple to implement. It kind of takes the advantage of the flat linear network, but just basically closes the loop at the end and makes a ring. So the advantage of that is we can tolerate a single point of failure, right? So unlike in the linear topology, if we had a break, we lost everything downstream. Here, if we have a break between these two switches, well, the ring will self-heal and basically, and this becomes like a flat linear topology at that point once we break that, one of those links gets broken. So typically here we're looking at DLR, device level ring, which Mike will talk about here in a few. But we also have some other, we have REP, resiliency, resilient Ethernet protocol, which is a switch level protocol for ring. That's a Cisco switch level protocol. So we can do one of two ways. We could do a ring of switches with a REP, or we could do a ring of devices with DLR. And one of the reasons why DLR rings are very common, besides it being pretty easy to implement, is they do offer a very fast convergence time. And what we mean by that is basically the time to recover if there was a link there or a break in the link there. The time for it to kind of self-heal is very, very fast, amongst the fastest of all the various resiliency protocols. So DLR has been very popular for most of our customers and installations.
And it's heavily tested up to the 50 nodes in the network. So it's something we know the outcome if you use this network, that it's a very robust, easy to implement network.
Yeah, good point. That's one of the disadvantages. There's this varying number of hops. So there is a limit, of course, and like we said, life is full of trade-offs. So there's a published limit to the number of devices you can put into the ring. So just to be aware of those design criteria before you implement. Okay, so that brings us into CPWE, or the Converged Plant-Wide Ethernet. And this is really just, again, more of a review. If you've been to any kind of Rockwell networking seminar before, you've seen this picture. So basically over the years, Rockwell kind of joined forces with Cisco, and they've come up with the blueprint for for this converged plant-wide Ethernet. And it's really, again, this is just a representation of kind of what you can do and see on the plant floor. We're kind of bringing the plant floor through the cell area zones down there at the bottom, up into the industrial zone and into the enterprise zone through an IDMZ or an industrial demilitarized zone. So just a nice representation of what you can do. The bottom zones kind of show those three various topologies we just showed a minute ago: star, ring, and linear topology. So you can deploy those on the plant floor, and you can even intermix them in those cell areas as well. But what's really nice about the CPWE is that there's an extensive amount of documentation there. It's not just, here's a picture and go figure it out. There's an extensive amount of documentation called design guides, as well as white papers that both Rockwell, Cisco, and Panduit is the third partner in these CPWE architectures. So like Mike mentioned a few minutes ago, all of this has been characterized and tested in a lab, and not just one lab, but multiple labs. Cisco has a lab, Rockwell has a lab. And so these architectures, these devices, these recommendations have all been thoroughly tested and characterized, is the term used a lot. So there's a lot here. Can't obviously go through every one, but for whatever your application is, I can guarantee there's going to be a design guide that will help you in figuring out what direction to go.
And just as a user of these design guides, I'll let you know they've actually broke them down into these smaller sections. That's why you see so many, but these are very easy to read. These are not daunting documents to take in. I would ask you to go reach out and take a look at some of these, because if you use a lot of this as our baseline documentation on how to design a network, I can almost always guarantee your network will always work.
Yep. So last slide for me, and it's kind of a transition into what Mike will pick up here on segmentation. It's just kind of, the next piece of that is, you've built your architecture, and now is practicing good segmentation, really organizing and segmenting your networks. And really the idea here is to prevent, so if some cyber incident happened in one of your segmented zones, it's not going to bleed over and impact the rest of your operations here. So keeping things organized and segmented will really help mitigate, mitigate potential for a larger disaster, shall we say, as well as just keeping, the things talking, in, whatever segment you want zone, those things should only talk to those things, and it prevents, things, talking in other areas as well. So I'll let Mike kind of take over on segmentation part here. I'll jump ahead. Oh, there's our fancy color. Just all right, let Mike pick it up.
Thank you very much. When we talked about segmentation, what we're doing here is getting away from when I first started with Reynolds 20 years ago. I had a sort of a network responsibility because Ethernet was sort of in its infancy on the plant floor. And I can almost guarantee you every plant network I saw was a large flat network, sometimes even tied into the business network. So that's where we started with 20 years ago plus. Now what we are trying to promote is segmenting the networks to only the people who need to see specific traffic. That we try to limit that traffic. So we've created different levels, the automation zones, the islands, that's levels 0 through 2 that we've talked about. We want to segment that from the rest of the network. We want to create an island of automation. So we do it in a couple different ways. I get questioned all the time when I've done layouts for people on their systems. Sometimes I will get a question like, why am I using 2 network cards when I only have a couple of banks of remote IO all tied to its own? Well, I'm trying to create a segment between the plant level network and the control network. In my mind, there's nothing on the control network, which is, that's where our IO, that's where our VFTs, our MCCs, that's where that resides. I want to segment that from the plant network. So typically in a ControlLogix world, what we do is use a second EN2T or a second EN2TR. So that's why quite often if you come to us specialists, we put that extra card in there, even though you might question why you need it or not. It creates a clear demarcation line. Control traffic will go to that EN2T, plant network, NIC goes to plant network. They do not cross. Now, what we can do though, to accomplish the same thing, if we use a switch environment, we can create virtual LANs, VLANs. Quite often we see people still are not using it. We have a lot more people using managed switches right now, but they're not creating VLANs for their networks. Where again, that's extra configuration, but in most switches is fairly easy to set up. It is easy with Stratus, and I've seen competitive products. Setting up VLANs is usually not difficult, but if you're not an IT professional, it can be a little intimidating. Now, what the difference is, we have created a VLAN that you see on the right. But you notice that they say the challenges are blurred network ownership demarcation line. Well, it's because the plant network and the control network are using the same switch. Wayne. So what we have done is change. We actually have used that same switch on the demarcation line, created two VLANs, one for our IO traffic, which would be VLAN 103. Then our plant-wide network is VLAN 102. That has created our segmentation. Again, in this case, we are still using two NICs and using the switch to create the VLANs. Still sort of that blurred network ownership demarcation. Is it IT switch or is it the plant switch? I can't answer that, but the fact is the two networks we have segmented them and controlled the traffic. So we have reduced possible issues by doing it this way. All right. And in this case, specifically, we're going to be looking at the compact Logix here. The new 5380 compact Logix, which separates itself from the 1769, we only have two Ethernet ports built into it. There is not an additional Ethernet card that fits in the 5380 chassis at this time. So what we do have the ability to split the ports on the on this. It can either support DLR as a whole, which means that port would be basically one IP address with like an unmanaged switch attached to it, or split it to two separate networks. That is how we're doing the network segmentation in this dual IP mode. Now, a couple of things to look at. We do not do class 1 routing between the EN2TRs when we have them set to separate NICs. We can do messaging across them. So basically, we're still the traffic across the backplane of the chassis. It's messaging traffic, and it's not so much direct control class 1 traffic. Just want to point that out. All right, Wayne, next slide. So this is just a general look at VLANs, because quite often in these, what we will call a converged plant-wide Ethernet, we're using the same network for multiple things. It could be multiple islands of automation, or in this case, what we're showing you is we created VLANs to segment our Ethernet IP devices, our automation network, from our voice over IP or our camera network. By that way, we're preserving bandwidth that the cameras can eat up. We're making sure they're not eating into our bandwidth by segmenting that traffic away. This is the type of approach that needs to be done, especially if you're doing this more of a converged plant-wide Ethernet. You have to come up with your logical VLANs for your devices. Now, quite often we're not seeing this. We don't see a lot of our customers putting voice over IP or their cameras directly on our control networks, but quite often we're seeing multiple islands of automation maybe running through that switch. Okay. Now, one other thing we do is for segmentation is use NAT, network address translation. So basically, I will say we're basically spoofing IPs. So what we're doing is we're created a subnet for the switch. And in this case, you notice that the controller is a 1010.3 IP address. Well, we're created two different VLANs that have their inside IP addresses are spoofed to the outside IP address. So the 10.10.10 IP address is spoofed to a 192.168 type IP address for everything in that island of automation. Okay, what's good about this type of segmentation is it allows you to keep the same IP addresses. Obviously, on a big flat network, we cannot repeat IP addresses. That will just cause tons of issues. Occasionally, that stuff does pop up if someone's not monitoring their network very well. We've seen that before. But this is a way, as you start creating your plant, and this might work for maybe some industrial OEMs, you can use this NAT device to keep the same IP address for all your equipment and just change it at the either the switch that handles the translation, or we have separate devices that can do it also. So this is a very good way of doing segmentation. If you're the OEM, you can keep the same IP addresses and you don't really have to worry about the address up top. That can be changed to that control system down the road. All right, Wayne. Now, in this case, what we're seeing, we have everything on the same network. This is one large flat network. This is what we're trying to get away from. This is basically it has a potential for congestion, especially as we get up to the not the distribution type switch, because again, the distribution switch is acting as one large flat network. So, and it's very hard to secure too. It's again being one large flat open. So what we would want to do is look at the zones or the cell areas for zones 1, 2, and 3, and make those their own little islands. All right, next slide. So what we've done here, you notice that the IP address for the cell areas now are all the same, but we're using NAT to change it to a different subnet for the line controller. So these are segmented islands of automation now. Each one has the same IP address range being used, but the controller still can see everything. All right, next. And here, what this is an example is, if we're not going to use a device that has NAT, we do have, I think in our case, we call it a 1783-NAT-R. We do have a NAT device that if your switch doesn't support NAT, we can use this device to basically do the same thing. So we can set up the segmentation or the IP spoofing. All right, now we're going to take a look at device level ring. This is one of the simplest networks to actually put into play, and it works really well. So the device level ring, not every switch handles it. I will say, always check and see if your devices do. This is not a Rockwell protocol. This is an ODVA, Open Device Vendor Association protocol, so anybody can use it. You will see some third-party people, users actually have devices that are supported on DLR. Just want to point that out, that this is not Rockwell specific, but they all have used the same rules. Now, DLR, we can do a mixture of things. We can use our managed switches. We can use our embedded devices directly on the network. That would be like an EN2TR. We also have devices called ETAPs for devices that do not support DLR natively. It gives us the ability to put that on the ring. I'm going to talk a little bit right now. I guess I'll deviate a little bit and the media being used here, you notice we can do rings at 100 meg, 1 gig, 100 meg. Excuse me, that didn't come out very well. But this can be a combination of copper and fiber. We don't care. If you're going to be using fiber, and especially single mode, you're going to have to use our switches currently has ring members, or our Flex 5000 now has a communications device that will, or a COM card, which will accept SFPs. So we'll use that. Those will be direct ways of supporting a 1 gig Ethernet. Otherwise, currently right now, all of our copper cards are 100 meg. The big takeaway from this is whenever you create a ring, the speed has to be the same throughout the ring. We don't care if you mix and match the media. You can get, the media can still be a mixture of copper, multimode, or single mode fiber, but the ring speed needs to be the same throughout. So I want to point that out. So in most cases, currently right now, most of it will be at 100 meg. But if you're using some of the newer systems like the 5380 and some of their cards, those ports are actually gigabit and can support that type of ring. Currently, the ETAPs are strictly multi-mode and they're strictly 100 meg. All right. Now, had the opportunity to use the multiple rings on a Stratix 5400. The 5400 is unique. One of the things that is unique about there's both a layer 2 and a layer 3 version of it. It's also it's an all gig switch, and it's also a switch that can give us a higher concentration of SFP modules in case we need to do a mixture of copper and fiber. Now, one very cool thing the 5400 does, it allows us to support up to 3 DLR rings. So I had an opportunity to use this. The City of Houston Northeast Water Plant is actually using a 5400 in this type of configuration. It's on the corner of the network and it's actually supporting 3 different DLRs. First time I got to implement it, and that was about 2 years ago. So it was a very nice way of breaking off the islands of automation specifically for this area. We have the same consideration. The ring has to be set at just the one speed, either 1 gig or 100 meg. No mixing and matching here. And again, we can support any type of media there, copper or fiber. All right. All right, this is a better breakdown of what we're doing. We're actually using a Stratix 5400 with 3 different rings, each one on its own different VLAN, as we're doing trunking there. This is a very good situation. This is actually pretty much what I did it with the City of Houston, and it worked very well. I have a high-speed DLR ring for where they need it, and we're running like an REP ring up atop to connect all the islands of automation. Now, in this case, one thing you notice, we're only where that the 5400 there is not a redundant gateway because we can't support the VLAN trunking needed to it. So that's why we only have the single gateway there. All right, Wayne. Okay, this is now I told you the 5400 can support 3 rings, but what this slide is showing you is something I see quite often. People getting just because specific protocols are on a switch, people can get kind of creative on what they do or use. In this case, sorry, Joe, I read your question. This particular ring, this would be the equivalent where the red X is, that would be equivalent of someone trying to utilize one of our Stratix 5700s, which can be a ring member, but to 2 distinct rings. That's a no-go. I've seen people try to do it and use it, the excuse, well, we're using rapid spanning tree for 1 ring and we're using DLR for the other. No, we do not support that. Just want to make you aware of this. Now, if this was a 5400, this could be a valid network. All right. Now what we're showing here is some of the issues here we can have. People will create rings within rings. And this is sort of the case here. This is going to be kind of hard to see, but what they have is up top, in the blue section, they're running either a resilient Ethernet protocol ring or a spanning tree protocol ring, and they're connecting a DLR to it. This will not work. The switches up above cannot support the device level ring. So this architecture would not work. So that's a nice thing. We're trying to show you stuff that won't work, but we see quite often in our designs. All right. Again, sort of the same thing. Where each time you connect to an EN2TR, use the 2 ports, you've created a DLR ring there. Well, they're trying to implement that into a spanning tree or resilient Ethernet protocol ring. Again, that's not accepted. So we can't do that. All right. And quite often, because I've often told people, well, you take your linear network and run back one single cable, make it a ring, and it's have some healing. Well, you still have to be aware of what's attached to the top, again, because we already have a ring with the in the blue section. The minute we bring that cable across, we've created two different rings. Again, our equipment is utilizing DLR, but the stuff in blue is using spanning tree protocol or resilient Ethernet protocol. That's a mix and match that will not work. Okay. Now what we have here is, again, we've taken a linear network, which is working, and we have connected it to a switch that is already utilizing another healing protocol for the ring, or I'm not saying it's a ring specifically, but for the healing of the blue section. We can't do that. Again, that's sort of like a ring within a ring environment. That would not be good. We cannot make this one work either. All right. And this is sort of just a follow-up slide showing that how we can support up to 3 different networks. And then in this case, we have 200 meg DLR rings and a gigabit. You know, the gigabit is using the 5069 ControlLogix IO, which does have a gigabit port built into it. Our Flex 5000 would also fit the bill there. And also some of our newer Ethernet cards and the Ethernet module in the L8 processor, those are all 1 gig out of the box. Again, copper is auto sensing, so it can also be connected to a 100 meg network also. So this is just showing a traditional way of using 3 DLR rings off of one Stratix 5400. All right. And last but not least for my slides, we can represent, if you're not familiar with it, there is a software out there called Factory Talk Network Manager. The device level ring can be portrayed in our Factory Talk Network Manager. If you don't know much about it, please reach out to your automation specialist. We can tell you about it. We can set you up with demos or give you something to take a look at. But basically, it will give you an overall view of your network and give us a really good look at what it is and to help us troubleshoot it down the road. So it's a fairly inexpensive. I think it's a yearly charge per switch on the node. So if you have any questions or would like a little bit more of an in-depth on this product, please let us know. All right. Okay, now we're just taking a global overview of so this is specifically a redundant ControlLogix system. One thing you notice, we are doing some segmentation using the NIC cards. You notice our NIC card at 1 is going to the upstream network. The NIC cards on 2, that would be what we'd be using for our control network, which would be our levels 0 to 2 type networks. Our islands of automation will be running off those networks. So this is a typical segmentation if you ask us to come up with something. And we have also included the distribution switches, and the core switches are also as part of this. This is a standard network architecture for us. We put this one out all the time. The stuff above are access switches. Those typically would be like a stackable, let's say Cisco 9300, something of that ilk is where that would reside. Now, as I just go down the numbers here, item 3 is our ETAPs. That's our device that is used to keep our product that does not support DLR directly, gives us the ability to put it on a DLR network. This could be maybe an old drive, maybe a single HMI, something like that. It could be an IO drop if we needed. Maybe it's an older IO drop that we want to put on this network. That's where an ETAP comes into play. We have also used them as media converters for multimode fiber also. The only takeaway is if you do use them as media converters, each ETAP does count as one node address. So that will count against your 50 nodes that you're allowed on the network. Now, switch number 4 is one of our Strax switches. Specifically, this is a Strax 5700 that supports device level ring. Big takeaway from that is not every 5700 supports device level ring. I want to believe they start with a handful of the 10 ports, but if you just search for Strax 5700 product profile, just do a Google search for that. That will bring up a document, and you'll see on page 3 there will be a table that tells you exactly which 5700s can support device level ring. And what we see quite often is our connections to our MCCs. Now, quite often we engineer this specifically. What we would want to do is put a switch on the end of the MCC run, because everything in the MCC is going to be a star or linear type topology. So if we want to add it to the ring, we generally will hang a switch off the side of it that will handle the, in this case, it will probably be a VLAN specifically for the MCC, and using a 5700 to connect to the rest of the ring. Now, Wayne, next one. And let's see, again, number 6 is typically how we would do one of our MCCs. It is usually a star or linear network inside the MCC bucket. Then we will use the 5700 switch in the MCC as a connection to the ring. We typically will use 2 switches when we do a redundant ControlLogix, one for each NIC card for our redundancy and self-healing. Now, this is so we can do a couple different healing methods, but we could do a redundant star from there, but we also could do another type of ring like resilient Ethernet protocol to connect those access switches. And also for redundancy, if possible, we will team NICs on our servers and our clients just for the added connections to the network for resiliency. And with that, now this is, I'm not going to spend a lot of time on this because we've just seen this slide. What makes this different is this is a converged network. This is where we're running multiple networks off our controller chassis. So you will see we've got green, blue, and red LANs for also being supported on this. So typically this type of architecture, it doesn't vary anything except we're using multiple NICs for the different LANs. So that's how we're segmenting in this case. Again, nothing really there. Again, we're using redundant gateways. Those are the Strax 5400s that are shown at let's see, 6 and 9. Thank you, Wayne. You're doing great cursor control. But this is how we get the more direct redundancy when everything needs to be backed up. Now we also do a redundant parallel star to our IO2, or redundant a PRP network to our IO2 if that's necessary too. But in this case, we're just using rings. Again,
Hey,
what's that?
Quick thing just to add, so just so you guys are aware, so redundancy for the L8 controllers as of version 33 only supports 1 controller per chassis. So what Mike is showing, you essentially have 1 single controller with multiple Ethernet adapters. Every color that he showed, that's a different DLR. So as he mentioned earlier, the Stratix 5400 supports up to 3 device level ring connections. So that's where you're seeing the connection in between that. So you're seeing 3 large DLRs, and then all of that is communicating up to the bigger network. But you are limited to a single Ethernet a single L8 5580 controller in an L8 style for redundancy. You can't have 2 controllers in that same chassis anymore.
Yeah, not at this time. And just as a takeaway, you also cannot use the Ethernet port on the controller in a redundant ControlLogix at this time. When we're doing redundant ControlLogix and you're using one of the L8 processors, the network adapter in it is locked out in version 33 and to be version 34 redundancy when it comes out. That is being addressed. I can't give you a timetable on it yet. So just to let you know, if we are using L8 processors, we will not be using the Ethernet port for anything in that redundant system. Okay.
All right, thanks, Mike. I think
I'm about ready to hand off. Yeah.
Yes, yeah, that was it. Yeah, so I should note too that these last 4 slides, the converged and non-converged, these kind of come from some reference architectures for redundant ControlLogix systems. So these are available for us to share. I think this deck will probably get shared after the fact as well. So you know, again, Rockwell helps document some approved and tested architectures. So
and this is also reflected in the CPWE also, Wayne.
Yep.
So I keep pointing back to those reference manuals.
Yep. So let's switch gears, and I know we're coming close to the top of the hour, so we can get through this pretty quick though. But last one is parallel redundancy protocol. So this is our other again for a redundant ControlLogix system. This will be our other approved kind of a network that we can go with is parallel redundancy. And you know, one of the things we saw, you know, in the ControlNet days, you know when we made the switch to Ethernet again, you know, we would always hear that, hey, ControlNet was awesome because we could do two LANs, LAN A, LAN B. And we didn't quite have that capability with the DLR architecture that we just talked about. So with the addition of the PRP technology coming into our products, we now have that ability to run 2 separate Ethernet LANs and kind of have that. That's a kind of a similar approach to our ControlNet type days. So the way our PRP, you know, PRP, parallel redundancy protocol. So as Mike pointed out, DLR, that's our ODVA protocol. PRP is an IEEE protocol, so that even opens this up to even more third-party products. But from a Rockwell standpoint, when we're talking about PRP, currently we're looking at the EN2TP. So this is ControlLogix, of course, the EN2TP, which is a different catalog number, the P at the end. That was our parallel PRP supported card, as well as the EN4TR. So that one doesn't have the P, it actually uses the R. So the EN4TR can be used in PRP mode. We're also now starting to see PRP come to some of our IO. So the Flex 5000 that Mike mentioned a few minutes ago as well also has the ability to support PRP to the AE and T adapter. So which is good. We're bringing more and more PRP to our products. So the way this works is real straightforward. There's some terminology here, DAN and stuff. But what's going on is we basically have 2 separate LANs. So that PRP card we talked about a minute ago, either the EN2TP or the EN4TR, you would have the 2 ports on that Ethernet card in the ControlLogix chassis. So one port would be LAN A, one port would be LAN B. So we basically would have 2 independent separate networks tied. So the LAN A, LAN B, and they could be either mirror images of each other, or they could be slightly different topology architectures, but there's essentially they're completely isolated or separated. And the PRP packet, Ethernet packet, will go through both LANs and will come back on the other end at the remote chassis, perhaps. So this is again going to be a PRP module here in this chassis. So basically whatever packet can get there first is going to kind of win the race essentially. So if anything happens along in LAN A that prevents that packet from getting here, then we have the parallel path through LAN B, and the card itself can kind of is smart enough to figure out which packet to use, shall I say. Now, where this kind of, so this is all pretty straightforward, but where it starts to get perhaps a little more complicated is when we have devices that don't support PRP, such as a drive or some of our older legacy IO products. Not always legacy, but our older products aren't going to support PRP. So in that case, we use what's called a red box switch. And right now, the Stratix 5400 is our switch that does support red box. And red box stands for redundancy box, basically, not the DVD people. So basically what happens here is we can now dedicate 2 ports on this switch. One as PRP ports, one will be for LAN A, one will be for LAN B. And it'll kind of bring those 2 independent LANs back together again. And then now we can attach our, what we'll call, these non-PRP supporting products to this switch. So they can participate in the PRP LAN through this red box switch. Now what's happening up here in this corner is a situation of SAN for singly attached node is that if I were to take like this panel view, and the panel view of course does not have PRP capability. If I were to just plug it right into this LAN B switch, well, this panel view is only going to be accessible or visible on the LAN B. So if LAN B were to go down, there's going to be no way that LAN A can communicate through and still talk to this panel view. So the preferred option would be, if you want to make this available on both networks, is have to tie it into a red box type switch. So the topologies here, the nice thing about the PRP is that we can utilize all the topologies we've been talking about. We can do linear, we could do star, we could do ring. So they're all supported. The other advantage of PRP is that we don't really have to have special switches here. Unlike the DLR ring where we had to have there are only a few switches that truly support the DLR protocol. Here, we don't have to have a special switch. We could use any Stratix managed switch that we want in this case. And because there's not really a PRP protocol per se that the switch has to handle, it's just going to be kind of a normal, network traffic going through this LAN A side. And then, over here in the blue, be kind of the LAN B side. The only time it really matters is, again, if we had to bring this, this type of device and tie it into the red box so that it becomes accessible to both sides. So again, down here, our IO, this is a PRP Ethernet module. This is our Flex 5000 with our PRP capable AENT module. And again, another ControlLogix chassis with a PRP card. So these guys are all capable of talking PRP direct. So we don't need to put a red box switch in between here and here. They can bring a direct PRP connection to these devices. So again, we could just kind of create a simple parallel network. So in this case, we're just again showing the variations here. So so we can actually do a ring. So we could do a ring on LAN A, and we could do a ring on LAN B, and then once again we can kind of bring in our panel view here through the red box switch. So again, we have the ability to be a little bit more creative here in how we do our topologies. Another way of displaying that, more of a traditional network one-line architecture, I would say, is like this, right? So once again, we can have red is our kind of LAN A ring, and blue is kind of our LAN B ring. So so it really gives us the ability to do redundant rings in a pretty simple manner. And star topology, same thing here. So we could just the first diagram we showed was just kind of a linear, daisy chain from switch to switch to switch to the device. Here we could, of course, set up star topologies to each zone area out in our plant. and just basically run, you know, a LAN A and a LAN B out to each zone. So some new things that have come about recently is again, so the EN4TR, that's a kind of a new module. We haven't really talked about it too much. It's been out for a little bit of time though, but the EN4TR is a couple of things about it. One, it supports up to gigabit speed in it. Two, it supports PRP capability. And three, it supports SIP security as well. And some of these releases came in firmware updates over time after the release of the module. So with SIP security, we can now do kind of endpoint-to-endpoint encryption. So for instance, we could you know, go make a SIP security connection, you know, from the controller down to the IO rack, and you know, and again, kind of encrypt or have this endpoint-to-endpoint security through a I could talk policy managers, kind of the tool that we would use just to kind of configure these zones and these conduits to make these encrypted connections. So we can do that, and we do, of course, over a PRP network now. So we can kind of get everything we want. We get redundant media or redundant LANs. We get you know, security features with SIP security. And one other ability of the EN4TR is we can actually do redundant adapter pairs now in the remote chassis. So, so that's been kind of another request we get occasionally, is the ability to put redundant, not only do we want redundant media, but we also want redundant hardware. And we can actually do that with the EN4TR module.
And it comes down to how much redundancy do you actually need?
Yes, yes. So we talked about NIC teaming there. So that is also something that could be done here on the PRP network. Typically, NIC teaming would be kind of done through the red box. That would be the recommendation. So if you have some thin clients or computers or servers, you can attach them to a red box and get them, you know, NIC team into red boxes and get them into the two LANs. What would not be recommended is doing a NIC teaming, but kind of bringing them directly to LAN A and LAN B switches as shown here. That would not be a recommended or supported architecture. Now, just like Mike had the DOR, so we have we have the two kind of non-converged and converged sample architectures here. So again, we can make these available. They're really good references. But just kind of highlighting some of the things here too, just like Mike was calling out. One, this is the non-converged. So basically that means we have you know, a separate Ethernet card that would basically be you know, kind of coming up into our enterprise or our you know, HMI layer up here. And then we'd have our PRP modules down below. Once again, we have our LAN A and LAN B. And again, the architecture here, topologies here are completely up to you, flexible of what topology you want to choose. But what's interesting here is we can, you know, really do some mixing and matching. Like for instance, we're coming to our red box switch here, and then from the red box switch, we can actually create a ring of devices through our ETAPs and stuff. Through this red box switch, we can go directly to our IO chassis, these two being ControlLogix 1756 IO chassis, and then we can also bring in our MCC through another red box switch, and then also maybe have a ring of various MCCs and stuff out here in our powerhouse through that as well. This just kind of showing, you know, this part was just kind of talking about some of the NIC teaming stuff, again, like we showed on a previous slide. So just kind of showing how maybe some of your thin managers and HMI servers would connect into this as well. And then just like we showed in the DR example, here's the converged version. So kind of the same thing where we have our 5400s here. And kind of, so we're using this one switch to kind of converge the plant floor and the you know, control and possibly the enterprise levels through this redundant 5400 pair here, and basically doing the same type of architecture we just talked about a minute ago. All right. So that was a kind of a quick go on the PRP, but we'll open up to any questions as we're at the top of the hour. We'll give a minute for anybody to type in a question or two if they have them. Again, like Mike mentioned earlier, any of the automation specialists with the Reynolds Company, we're here to help. We can help answer questions on various topologies, various technologies. We get those questions quite frequently, so always happy to help.
And we're always welcome to look at your network design.
Yes. Just wait 1 minute and see if anybody types anything. If not, we, as always, appreciate your attendance. And like we said earlier, this same session will be repeated as the Houston session tomorrow. So if there was somebody that you thought should have listened to this, they can also join in tomorrow. I think tomorrow it starts at noon versus 10, if I'm not mistaken.
I believe it's
Mike?
11, but we will give you a free sandwich.
Oh, yeah.
Provided you register.
If you're showing up in the real, in person, absolutely. Free sandwich. If you're online, then you get to hear everybody eat. And I guess we'll close out. I don't see any questions. And Joe is complimenting us. Thank you, Joe. Good to hear from you. And we will close it out. And once again, thanks everybody, and have a great day.
All right, thank you very much.
Bye.
Bye.